Welcome to today's presentation on a powerful but typically forgotten feature of SDS's VIP monitor, the batch trace. Let's look at the tracing available in VIP. If you're already fortunate to have the VIP monitor running in your environment, you are already probably familiar with the trace tool on the VIP UI. If your site does not have VIP, you need it. Just the trace tool alone is worth the cost. So you need to trace data and packets exchanged between the client and server. With the VIP user interface, getting packet trace data is easy as selecting options on the VIP trace definition panel, then clicking on the Start button, then watching as the packets appear in the trace display as activity occurs. It's as easy as that. End of story, but hold on. There's a significant oft-forgotten VIP component which makes the online packet trace pale in comparison. The VIP batch packet trace does much more than the online trace, as evidenced by these functions the batch trace performs, which the online trace does not. Some of the more notable benefits are trace socket data, trace packets on the OSAs, being able to schedule when a trace starts and stops, start or stop a trace based on a trace string value, filter trace entries based on a string, display IPsec and ATTLS data in clear text, export trace data sets to the VIP GUI IP Trace Manager. VIP batch traces can be coded once and scheduled to run later or multiple times, and they don't risk losing data when the trace buffer wraps. Let's take a quick look at the batch trace. This example combines the socket data and the IP packet traces into one trace so that you can see data flowing to and from the applications and the stack. Think of the benefit to application developers and support personnel as they can see commands, responses, and data at various layers of that TCP/IP stack. Data can be seen unencrypted before it's securely sent or after it's received from the network. So with this job here, we have our IP packet trace command, tracing everything to 10.0.1.146 for the TCP protocol, and the socket trace going to the same IP address. The resulting output will show the entire data payload and the IP and protocol headers for those packets. Submitting the batch job, we can go over and look at the results. And generate some activity. And then we can see the result in the trace of all the activity that we just traced. So P here indicates this was a packet trace entry. So we can see as I did commands in that FTP session, received at the stack, the socket trace entries then being forwarded over to the application. And then when the application responds, we can see it going back from the socket layer out into the stack. So now you have a really good idea as the packets are going through the entire TCP/IP environment on the mainframe. The batch trace template created by the VIP agent installation handles many of the coding steps, allowing you to quickly configure and start a trace. For IP packet traces, define one or more statements to include or exclude packets. When multiple statements are present, filtering of each packet is performed by the order of the filter statements. Each packet socket trace entry is examined individually. If the traced entry contains IP address 10.0.1.129, it is selected and no other filters are examined in this case. If the trace entry does not contain an IP address of 10.0.1.129, the second filter is examined. If the trace entry contains port 49260, it's rejected, and no other filters are examined. Finally, if the trace entry has not matched either of the first two filters, the third filter is examined. Then, if the trace entry contains port 23, it's selected, and the practical result is that any trace entry that contains an IP address of 10.0.1.129 and any entry that contains port 23 but not port 49260 will be selected in part of the trace. Socket data filtering operates the same way. Define one or more statements to include or exclude packets. When multiple statements are present, filtering of each packet is performed by the order of the filter statements. And it's very important to note that you can combine IP packet trace filters and socket data trace filters in the same job. This can be a very powerful feature for application developers, allowing them to see the interaction between their application socket calls and the network. For OSA traces, all filters with the same port name apply to the same OSA device. You may supply filters for more than one OSA. The last OSA entity statement needs to have the on parameter to start tracing. Post-capture filters are applied to the trace entries after they have passed the filters specified in the packet trace, dat trace, or OSA entity statements. The post-capture filters can be used to start, stop, limit packets to the strings specified in the filters. IP and socket trace input can be from the live data, a dataset, or a DD name. Trace output can be directed to the job or a dataset. Trace limits are optional and can limit the trace to a specific number of lines, packets, or time. There are various options available to format the trace output to allow you to see the packet headers, data payload in raw, ASCII, and EBCDIC format. And if data is secured via IPsec or ATTLS, be able to see it in clear text. Various IPCS format options are available, including a summary, full, and brief formatted report. So in summary, the VIP batch trace offers valuable features not available on the VIP GUI packet trace, including gathering socket data and OSA traces so you can see the traffic at various layers of the TCP/IP stack, setting the dates and times to start, stop a trace, specifying triggers to start or stop a trace, additional filtering so you can only view the packets of interest to you, and if authorized, see IPsec and ATTLS data in clear text. Use all the powerful ISPF tools like find, exclude, copy, paste, and highlighting. And if you need to show the results to your manager and you want it to be more visual, either export the packet trace data to the VIP UI or an INC format to Wireshark, then view the trace data through one of those user interfaces. So take advantage of the batch trace to stop having your developers bug you to run packet traces. Provide them with a VIP trace manual and a sample of the batch trace job, then they can run their own traces, including the socket trace. Now that you know about this feature, it's time to share the news with your colleagues. We're confident productivity will increase in your organization when using this hidden gem. Thank you for attending the presentation, and we look forward to hearing from you soon.